migrating a component, writing a line of code, etc., etc.
Sorry, excuse me. I just received a message here that they were saying that we had a problem that we didn't go live. So I'm so sorry about this. Would you mind starting from the beginning?
Yeah, absolutely, no problem. Did that just happen now? Let's start from.
Okay, sorry about this, everyone. I'm just going to do a quick intro again.
Yeah.
We are GDG Cloud London. We're going to have 2 speakers at the moment. We're sorry there was a problem that the streaming didn't go live, but now we are here and the speakers are already set up and we're going to start at this very moment.
Brilliant, thank you. Okay, hi everyone. So today you have got myself and Hugh Price on the line. And we are going to be talking about de-risking migration from mainframe to the cloud. So hopefully a relevant topic for a lot of you on the call today. Myself and Hugh are from a company called Curiosity Software. We've been in the software industry for probably a bit too long, but basically a lot of the projects and companies we are involved with are revolving around helping them increase quality, helping them automate more, helping to get test data into the hands of testers and also developers so that they have the right data they need to perform their tasks. Okay. Now, both of these topics are obviously quite relevant to migrations. So that is why we're kind of chosen this topic, and we're working with many companies at the moment on helping them with their migration projects with a particular emphasis on migrating from mainframe to the cloud. Okay. Now, you know, if you look at the industry at the moment, migration is actually absolutely pinnacle right now. You know, there's so many cloud-based vendors out there, which companies are looking to kind of move on to, you know, cheaper infrastructure, readily available infrastructure. You know, you look at companies like Google, AWS, Azure, etc. But also there's an awful lot of companies out there right now that are disrupting because they have the ability and newer technology in front of them that they can move much faster. They can leverage all of these great libraries that are now out there, which is pretty hard to do when you've got some kind of legacy system in front of you. Now, the biggest challenge that we have actually seen, and hopefully some of you will be able to kind of resonate with this, is that most migration projects actually fail. And there's a little statistic here that 38% of migration projects actually fail. Okay. Now, the reasoning behind this, certainly from what we've seen in the industry, is actually often there's, you know, certainly a level of limited understanding. There's a level of technical debt. There's often very limited documentation in terms of these systems that are to be migrated. Okay. And with that obviously brings, you know, inherent difficulties. If no one understands the system, then it's obviously very, very difficult to come in and start to figure out how to migrate it, what the business logic is, what all this business terminology means behind the scenes, and how it's being, you know, interpreted and decisions are being made by the system. Okay. So the goal of this session, we are going to show you quite a lot. We're going to go through it quite quickly. But hopefully the goal is that we can give you a bit of a glimpse into some of the processes, some of the methodology, some of the tools that we're using in the migration projects and the companies that we're working with. And really the main mantra here is really about introducing quality as early as possible and getting all your kind of ducks in a row. So you've got your test data and all your dependencies there before you even start thinking about migrating anything or a component. Okay. Now, the pinnacle point of this is, you know, firstly, we need to get everyone on the same page. Everyone needs to understand what is to be migrated, you know, what knowledge there is of the system, how the system works. So everyone has a clear understanding of what is to be migrated and what the source application does today. Okay. And the way we're going to do that is mostly through visual models and modeling. And that is all about exposing the system in a very visual oriented manner so that anyone can come in, they can see what this particular component does, everyone can get a clear understanding, and everyone's on the same page before a component is even migrated. And the main piece that we're trying to drive through here is we should be able to find bugs much earlier. We should be baking in quality, you know, right from the start. as soon as we have a new requirement, let's start thinking about how we're going to test it. Let's generate the test before we even start coding anything. Improving collaboration, getting everyone on the same page, and just using quality to drive the migration. So I'm going to do one slide just to talk through the kind of process that we've typically been going through. And this is going to be very much based around some work we're doing with a credit rating agency in Brazil at the moment, who are migrating from a legacy 3270 green screen application over to the Google Cloud Platform. Okay, and we'll give you a little glimpse of this afterwards into a demo, and then I'm going to hand over to Hugh, who's going to walk you through some more advanced data pieces. So whenever we're migrating an application, typically there is something. There's a procedure, there's a function, there's an operation to be migrated at the beginning. Okay, and hopefully there's going to be some requirements associated with that to say what it actually is that's going to be migrated. Now, the core piece that we bring to the party is actually a tool called Test Modeler. And this is a very visual tool. It's a collaboration tool to help people understand how systems work and to help get people on the same page over what is to be built and implemented. Okay. Now, this particular project was incredibly successful because, before anything is even thought about being migrated, people are holding a call, for a couple of hours, getting all the stakeholders involved who have any knowledge of that system and building out a visual image over how that part of the application works currently today in the source application. Okay, so it's all about collaboration, building out that visual image of how it all hangs together. Okay, once that model is created, you can actually generate test suites from it automatically. You can generate automation for the source application. You can overlay rich sets of test data from all sorts of different test data environments. And finally, you can push out the automation as well. Okay. And crucially here, you can have traceability back to any of the requirements that initially come through. Now, once we've got all of that in place, we've actually got our test cases already built for the target application. We've got our automation moving along. We've got the test data we need to migrate the application. Hopefully someone's going to come in and actually migrate it and move it over to whatever platform that is, maybe in the cloud, maybe on premise, maybe some kind of hybrid solution, but somewhere that application is going to get migrated. The project we're actually going to be looking at and talking about today was moving over to a Java-based web platform. And for that, we actually reused the same models that we produced for the source application, and we were overlaying web-based automation in Selenium to go and test that migrated application. Okay, and the whole idea here is that the source and target application should mirror each other. So by using the same models, we're assuring here that the source application works in exactly the same way as the target application. And this is pretty crucial for any migration. The source and target should operate in exactly the same way. And that is what we're using here to assure that that migration of that particular procedure component has been successful. So I'm going to jump in here and show you a little bit of context and color behind what that actually is. So I'm going to shoot over here to a tool we've got, Test Modeler, and you'll see that this is a web-based tool. We've actually got a cloud solution, which is what we're connecting to today. For much bigger customers, we provide an on-premise solution as well. But the main benefit here is users can log in, and it's all about collaborating together to build out models, to build out test data, to build out automation, and collaborate on that migration journey together through the different stakeholders. Now you'll see here, we've got a few different models that we've got. The first one here isn't terribly exciting, but if you take a look, we've actually got a model representing a login screen. Okay, and hopefully you can just immediately see this is a flowchart. And from this login, we can either end up authenticated or there's some kind of error. And in between here, we've got lots of routes in between. Okay, that's basically what I'm talking about with a model. It's a flowchart, and people can come in and you can visually understand and see this is how this particular process works. Now, the main benefit of modeling is once a model has been created, they can be linked together. And here, what we have done is we have built out a bit of a bigger process where we're logging into the application, we're submitting a batch job, we're going to go and retrieve some results, and then we're going to perform some assertions at the end. And if we open these up, what you'll see is that actually inside here, we've got different sets of combinations, different business rules, and different expected results being passed through inside this flowchart. Okay. Now, as I said at the beginning, the company we were working with on this particular project, it was all about driving quality from the very beginning. Okay. And basically, this company would have an 2-hour meeting, get everyone on the same page, what it is we're migrating, how it works, build these models out, and then connect them together to build them. Okay. Now, once we've got these, we can come in and we can generate different paths through the model. And if we take a look here, what you'll see is that we've got several paths that have been generated. And we can flick through these and you can see the different combinations and the different routes they are taking through these different models. Now, these actually represent our test cases. And from the outset, we have said, generate me the minimum number of tests to maximize coverage across these models. But we can be much more flexible, and you can, start to incorporate tags and really, focus the test cases on particular areas. Now, on these models, we've actually overlaid some automation. And if you look here, what you'll see is we've got 2 types of automation that have been overlaid. We've got some mainframe automation, and we've got some Java Selenium automation. Now, this is representing the end result once the application has been migrated. But if you look here, we've got 2 types of automation. And from these models, we have basically gone out and produced different types of automation scripts. And if we look at the results here, what you'll see is that we've got some screenshots of the actual mainframe application as we've gone through executing these different paths, going through the various screens, the TSO menus, etc., submitting the batch jobs, getting the results. So this is the automation and the results that have been collected for the source. But then also here, because we've reused these exact same models to test the target application, what you'll see is layered on top here as well, we have automation results that have come back, which are testing this target application, which is actually a single page application, which is being used for submitting batch jobs as well. So hopefully this is giving you, a little bit of insight into what modeling is. It's very, very visual. But once we've got a model, we can use that to drive all sorts of different automation. We can feed it through different automation frameworks for different platforms, web, API, mobile, mainframe, and all sorts of messages and different types of data as well. So Hugh, do you want to pick up and carry on?
Sure. Let me just make sure that I can share my screen. Okay. Entire screen. Allow. Okay. So question is, can you guys see my screen at the moment?
I'm not seeing anything actually.
I think Amanda, I'm not sure whether you have to. Oh, that's interesting. Is that me?
I just added your presentation.
Cool.
Just make sure you edit in presentation mode.
Okay. Can you see de-risk mainframe migration?
Yes.
Okay, cool. Right. So basically what I'm going to go very, very quickly, hopefully some of the words will stick. At the end, I'll put in the contact details so you guys can stay in touch with us. In effect, what James has been talking about here is, in effect, creating this kind of concept of a model and the ability that, when you're migrating, in theory, the applications should be the same. And what James has very cleverly done there has been able to create from the one model the automation scripts to validate that you're getting the same results from the migrated application. Okay, so that's kind of what James has just been showing you. Now, there are a number of other little areas which may well be interested to you. Now, we're talking about mainframes here, but also there's quite a lot of migrations, up into kind of microservices architectures, etc. at the moment. So a lot of the techniques that we're talking about will apply to those. Now, there's an interesting area that we're doing a fair bit of work of, and there's a company called For Theorem that we work with in Ireland. Really cool and very clever guys, a bunch of physicists. And what they've done there is that they've in effect, they can scan the code. Now, normally on a mainframe, you're looking at COBOL and assembler. In this case, this is a Java application that we're looking at, and they're actually looking at the class calling structures, and they're looking at this in this diagram I'm showing you is a static analysis. But actually, if you can also do a dynamic analysis. So actually, as you run the application, so if you attach that, for example, to James's automation test, you will actually see which components of code, which classes are actually being executed, and that is stunning. I mean, that really is a very useful way of being able to kind of understand what's going on with the application. And what you're actually kind of interested in terms of the initial static analysis is creating these little strands of DNA. What you really need to worry about when you're doing a migration is it is almost impossible to do a big bang migration. You need to think about clustering. You need to pulling out, you know, it's a microservice, you've got to pull that microservice out. You know, if it is parts of the system, you may well have to pull some of the message sending from one system and the message receiving into other systems. So you're doing source code, you're collecting agencies, you've got analysis and filtering, cleaning, domain analysis. But the idea is you're trying to build these clusters of code that are appropriate to be migrated to the new platform in sequencing. And I think that's really important. I would say it's worth spending much more time up front understanding which bits of the application you're going to migrate in what sequence than it is to just pile in and start doing stuff. So I think that's from the code point of view. Now, the other thing to really understand is the data. Now, data-driven migration testing. Data is the truth, not what people think the application does. So, you know, having that common understanding, especially with a lot of systems, mainframe systems are actually vast message systems now. They're just messages moving around the application. Now, a lot of people think they understand how the system works, but actually they don't. And it's very expensive for people to sit around and chat, whereas actually if you analyze the data, and that is the static data that sits in systems and also the messages that flow through the system, that is a really quick way of being able to do that kind of understanding of what's actually happening. You know, when you post a Swift 10, a 103 and a 202, tell me what has actually happened to the databases behind the system, and just do a comparison, and you can actually see what's going on. The other thing is to think about the problem with the data in a legacy system is that it's got loads and loads of bad data. Now, bad data is in the eye of the beholder, and it's irrelevant now. It may well have been migrated into the system. It may well be data which you're never going to use, but you don't want to lose it. Now, you have to make some very clear decisions. Do I go to the trouble of cleaning the data up to make it work in the new system, or do I ignore it? I would say that is probably the biggest problem that people don't think about is, oh, we got all this bad data. What do we do about it? And bad is not just data which is sort of malformed, or you don't fully understand what the overlays are. It is, you know, an understanding of what an address is. You know, address must have a zip code in the US, but they didn't have zip codes. You know, in Ireland they have zip codes now, but they don't have zip codes then, you know. So that's really important to spend some time thinking about the data and understanding it, and also then making decisions about what you're going to do about bad data. And this is true for every kind of ETL expert transform and load project, but it's especially important for migrations. The other one is masked data. Masking data is, do you really want all the people working on the migration having access to your production data? And the answer is no. And you know, GDPR, is just really strict about this. Your migration team shouldn't be looking at live data. However, they will immediately say, well, how can we test the system works if we don't have access to live data? And the reality is that you need to mask the data. Now, the masking of the data will change the names of the innocent, etc., but you need to mask them consistently across multiple systems, because you're not going to be moving one system. You're going to probably be moving an AS400, a Java application, and all sorts of different things like that. That takes time, and you need to spend time upfront kind of getting your head around this and actually spending the time sorting it out before you even start. And that's going to cost you money. Create small regression packs to run against old and new. Difference equals 0. So looking at the data, looking at the migration that James was showing you, that was fine, because it was probably just entering data on. It was adding data into add screens. If you're trying to make sure that reports match, you've got to make sure that the data from your source system, which is your old system, and your new source system, which have been migrated, so you might be moving to something like Oracle Cloud or something like that, or maybe Google Cloud or something like that, Now, that's fine. There's a migration going on there. The application, old and new, in theory, you should have zero differences as the data moves through. Now, one of the big problems is that people will say, well, let's just move all 27 million rows of data over every single time you want to run a single test. Now, that just isn't practical because these jobs would run for a long, long time on development boxes. So you really need to think about how you're going to segment the data. So you're suddenly into an understanding of what actually subsetted data is. The bit in the middle is if you are moving data and you are making changes to your application, which I would strongly recommend you don't. You just move apples to apples. You're just looking at the technology stack wherever possible. You are going to have to test the transforms as well, because you can't compare the data anymore because there's an actual difference in the structures of the data. Cleaning up obvious things is fine, but actually fundamentally merging tables and splitting tables out, you can do it later as a phase 2, and that's perfectly fine. But trying to do it as part of the migration is problematic. Now, a really important thing to think about is the clustering. How do you cluster? Previously, we were looking at the great stuff from 4 Theorem, and they're looking at the code, and the code naturally breaks itself into smaller components. And you might have to do some plumbing, get all the plumbing moved over, and once you've got the plumbing moved over, you can probably start picking off some of the higher level endpoints and moving them over. That's fine. But for larger migrations, you've really got to think about how are you going to move pieces of the application, because no one ever goes for Big Bang. If you go for Big Bang, it's almost guaranteed to fail. You're going to have to do parallel testing for ages and ages and ages. So a CRUD map, basically create, read, update, delete maps for everything. If you don't understand what a process, which tables, messages it's creating, reading, or updating, or deleting, you really have no idea, and you cannot build a clustering strategy. So here we've got some old applications, 1 and 2, groups of tables, 1 and 3. You can see that some are reading and some are updating. Now, once we move them to the new platform, you basically are taking this part of the application over here now, and this is in the old world. So you're actually living in this hybrid world. Now, this is problematic in that the red means that we now have data in one system and applications in another, and you're communicating across like so. Now, I put it as red because that is a piece of technology that is going to go away. How stable is it? How much do you want to spend on it? How reliable is it? How robust is it? And also what happens when it goes wrong? Now, this one here, this is an old application. Nowadays, it's not a problem to go and look at data on open systems. You can look at data from the mainframe out, so that's fine. I've left that as yellow. But these ones where you're actually having to synchronize data back and forth, which means if there's an update in one system, it synchronizes back to the old system. That is a problem. And basically, you need to test that very, very thoroughly, because if that goes down, you're in big trouble. So let me just kind of quickly summarize this up, because we do have another speaker. Do the data migration before you begin migrating code. I cannot stress how important that is. If you start looking at the data up front before you start looking at the code, or certainly in parallel, and devote time to it, as opposed to looking at the code, migrate the code, and say, oh, we need some data, you'll basically, the whole project is going to be double or triple in time. Do not change the functionality in the application. 38%. I have seen up to 56%. It depends who you're reading. And mostly the reason they fail is people say, oh, well, if we're going to do that, why don't we just add in a new drop down? Or why don't we centralize the code templates? Or why don't we add in some extra features and functionality? If you're doing platform migrations, wherever possible, try and stick with the core functionality. You can hide it. You can use triggers and things to mess around with the data. That's fine. But as far as the application is concerned, it looks the same. So you've got to be very careful about how you adding in additional functionality. Add it in as phase 2. Clustering is massively important in terms of understanding how you hop and how you implement certain components of the system, and they synchronize. Keep synchronization to a minimum. And that's a minimum in terms of the technology, and also the volume, and also how long that synchronization is going to have to stay in play. I was talking to actually my son, who works for a company, yesterday, and we were talking about, there's a very large German bank who got halfway through a migration to SAP banking, basically had a new CIO, threw the whole lot out, and now they have both systems. So they in effect have synchronization between 2 technology stacks, whereas before they only had one. And now they have to maintain 2 stacks plus the synchronization between the 2 systems. So you've got to be very careful about that, and that's not going to go down well with the board. Test the synchronization. If you are synchronizing data, you need to make sure that it fails. If it fails, you have tested it and there is a rollback position, because what you'll have is you'll have basically data being updated in two separate systems, and you now have a new problem in that you have to equalize the data which is dominant, and if both people have updated, you then have to notify someone that a change has been made, which is additional functionality. So there is all sorts of things to worry about to do with that. Okay, that was a very fast touch on some of the issues. If you want to talk about it at less pace and actually look at some of the stuff that James has done, we can. I've probably actually had a migration company for about 5 years, so I've migrated probably about 20 companies off mainframes. We're also working with a great company called Legacy IT. If you want to look them up, they're really cool. They do some really good stuff. For Theorem, also very good. But in the meantime, if you want to just have a look at curiositysoftware.ie or get in touch with James or myself, or just track us down on LinkedIn or just use these emails, then fantastic. We'd love to talk to you. And this could be for migrating from a mainframe, or it could just be a general strategy about automation, or it could be moving to microservices architecture, or it could be improving your message testing or so much other subject, which is another one of my favorite topics. Okay, hopefully that was a bit quick, but hopefully you got the idea. And if I pass it back to Amanda, I do believe we have another speaker.
Thank you very much for this. So you gave us your contact. So if anyone has any questions, if you'd like to book a meeting with them, you have the links. This is recorded, so if you didn't have the time to see it, you can just go back in this YouTube video. Thank you very much for being here with us, to the two speakers, Hull and James. See you
Great,
later.
it's good fun. Thank you very much. Bye.
Thank you. So just a note that our second speaker can no longer be with us today, but I have someone who was able to come here last minute. I'm going to bring her in to be here with us. She's going to have a chat with me, and we also have a second Google developer speaker, a woman who's going to give a talk after her. So this is very exciting. I'm going to bring her now. Hello.
Hello. It's me in pajamas. I just had my COVID vaccine, so I decided that it was time to just relax at home in jammies and kind of rest it off. So far the experience has been interesting. I apologize for the lights. I'm actually going to move to a better setting so you can see me. Much better than before, right?
We can see you.
You can see me. Excellent. Well, it is definitely a privilege to be here with you today. I am a big fan of your events and everything you do. I have to say that definitely I feel privileged to even be sharing the virtual stage with you. How you doing?
So I introduced myself, so I think it's your turn. Who are you?
My name is Diana Rodriguez, and I am a Google developer expert in web technologies, Google Cloud Platform, Google Maps Platform, Firebase.
So what are you not a Google developer expert? So you mentioned you took the shot today. How is it feeling?
I took it yesterday. Well, I immediately experienced a little bit of fatigue and my arm hurt. And today I feel like my arm is going to fall off. And I've had a little bit of malaise, but it is definitely worth it. There's nothing that I long for more than to be out there and travel and see people. And I never thought I would say something like this, but I actually miss people.
People, they're awful. Well, we miss you, and I can say I miss you a lot. I used to see you so often in all the conferences all around the world, and now I can only see you from a screen. So we were talking earlier about some exciting projects that you've been. I mean, you'd never stop, and I think it would be very interesting to share with the community, especially because most of the things you do are for the community. So if you could share a bit about your projects.
Definitely. Well, I am very excited to introduce Euler to everybody. I will actually share the websites in the private chat with you, Amanda, so you can share it with the rest of everyone while I give you some context. When the COVID pandemic started, nobody was ready to go everything virtual. Entire companies, communities, in general, families, like these dynamics were altered in such a way, and we had to step up the game. I remember the first talk I gave. I'm not going to name the conference, but I had to log in to 5 different apps, and I was sharing slides in one, audio through another one, video in another one, and then Q&A through a different one, and then the actual conference was in a separate application. So there are a lot of popular solutions like Zoom, like StreamYard, like Crowdcast, and household names that we know, and they're very good, even Hopin and everything. But there are specific problems that they haven't resolved, and my team and I were determined to make the David Bowie of streaming apps. We didn't want to spread too thin. We wanted to get the best of everything and turn it into a product that could answer the necessities, the needs that we have as event organizers and as speakers. And the premise was to make the lives of speakers, attendees, and organizers alike easy. So our motto is online events the easy way. We have a very intuitive interface, role-based authentication. It's a very lean app that can work even in the slowest device, even with limited connections. Like we've put forward a lot of technology and infrastructure to make sure we can offer the community something reliable and lean at the same time, because it has to be accessible. And it was a challenge to actually try to find creative ways to overcome these hurdles without impacting users, impacting pricing, impacting the community. And we actually offer our platform for free for communities who need the support, and we're happy to support your events, and we're happy to also sponsor in many other ways. We are rolling out another special feature, and it is a way to guarantee interactions between sponsors and attendees, and to actually make it a rewarding experience. And I'd like to extend an invitation to all those out there who are part of a community. If you want to try, there's a link to apply in our website. And I know our website is not even up to date with all the new changes and all the new things that we have in store, but our social media accounts are, and you can follow us on Twitter too. We post updates. We post pictures of cats too. But what we want to do is make communities, be a support for communities, make your lives easier, make it easier for speakers. This is something that is built from the community perspective, and I want to stress that we want to keep this community support ongoing. And yeah, we're very open to help out. It's a platform for private events. So no trolls, no unwanted access from undesirables who like to disrupt events. I had situations where, a few months ago, I was in a Python event, and some random man just enter a Cisco WebEx webinar absolutely naked, and we couldn't kick him out. So it was really stressing.
I had something similar. I mean, not similar to that point, but we were hosting an event, and then it was a Meet event. And then like 5 people joined, and they were sharing their screen and music, and we kept on kicking them out, and they kept on coming back. It was a nightmare.
I know, right? It's crazy. Or even think about taking it to the next step. Accidents in events things like if you forget to mute your microphone, it happened to me in a conference in Southeast Asia. I burped live on, in the middle of the event.
Forever. Now everyone is going to look for the video.
Oh my goodness, yeah.
No, really, we as UDG Cloud London, we can't wait to use this platform. It's going to be amazing for the community. And as I said when I welcomed you here, you're all about the community. So you shared about this project, but be sure to also share all your other social media contacts. I see you have your Twitter here, right?
Yes. There's also, for those who are interested in IoT, I developed an application for type 1 diabetic patients. It's a Python and Firebase application that it's really friendly. Anyone who wants to contribute can do so. I have a sensor here. Oopsie. As you can see, it's a blood glucose sensor, and it monitors my blood sugar 24/7. And sometimes I'm low and I'm unaware, and I get alerts on my phone. And if I happen to be in danger, it would basically send a message and call as well my emergency contacts. So we expanded this to the next level and added a GPS tracker that doesn't work with mobile internet, but picks up LoRaWAN, which is like, it's pretty new for the consumer. It was very popular with industrial IoT. And there's this provider that I love. It's called Helium. They actually sell hotspots. They call the People's Network. They sell hotspots that you can power up from your house and mine crypto for the traffic you get, for just having the hotspot on and offering coverage. You get rewarded. And I thought it was a good combination to make sure, okay, we expand coverage. And then now if I am in the middle of nowhere and I'm low, my emergency contacts will get a text message with my precise location. So that's something that I am very proud of. It saved my life 3 times. And, we're here to make a difference. I think that sometimes we take our superpowers for granted, and sometimes we don't realize how much of a positive impact even the little knowledge we may have, the more knowledge that we have can have a positive impact, and we can use those superpowers to do things for good, tech for good, right?
Yeah, this is very motivational. I feel like, I don't know, printing your words and putting here in front of my screen.
Thanks.
Well, super exciting to hear about your two projects. Thank you for being here with us, even with like your arm and everything of the shot you took. Thank you so much, Diana. Talking about Google Developers Experts and cats, I have someone else I would like to invite now. Thank you so much, Diana.
Thank you. Have an awesome rest of the event. I'll be watching.
Well, what a pleasure. So, thank you very much. So we have another speaker now who is also from my country and also is in the country where I am at the moment. Let me bring her in. Hello, Daniela.
Hello.
So good to have you here. Thank you for coming here. Both you and Diana was like, oh, my speaker is not coming. Can you come here in 20 minutes? And this is the power of community. I have 2 women supporting an event. I'm so grateful for you to be here with us today. So if you could introduce yourself and talk about the talk. Talk about the talk. Of
course. Yeah. I'm still trying to adapt to the. Actually, as you know, I didn't have a plan to speak today, so I'm trying a new setup here. I have a new mic, a new camera, so I might look a bit confused because I still.
Are we your first
Yes,
first time you're using all of that?
Yeah, this is the very first time I'm using this mic and camera, so yay! Talk about doing things from live. Okay, so I'm Daniela Petruzelek, and I'm a data architect. And actually, let me share the screen. Oh my God, it has been so long since I did a talk, I already forgot how things work. So here.
Probably don't even have permissions anymore. It always happens to me at work. Teams, I never have the right permissions.
Yes.
Yeah, so both Daniela and I are spending our lockdown here in the UK. Where is everyone in the chat chatting from?
Okay, I just need the permission.
No, it's fine. Take your time. Yeah, I also got new lights, but I haven't learned how these things work. So sometimes I make myself too yellow. Sometimes I'm too, I don't know. I'll get there at some point.
Okay, let's see.
I think this is good. I also got like a green background, but I'm also learning how to get the right lighting so that it doesn't show up. UK, there's Stone here from the UK. Exciting.
Okay, I need to log out and relog in. I'll be right back.
That's okay. Let me talk to you about the events that we're hosting this month. Only this week we hosted 3 events. Next week we have another one. We have 2 Google developers experts who are going to talk about machine learning and web technologies. And I think that's going to be all for March. Oh, we also have one event that's happening throughout all the month. It's about actions on Google, so you can create conversational actions. And we have a Discord community that you can ask your questions, you can share about the projects that you're working on. Daniela's back. You can share about the projects you're working on, and in the end, we're going to give prizes to the best implemented ideas. So it's kind of a month-long mini hackathon. So there's a lot happening with GDG Cloud these days. We used to see you so often in real life, but now we're trying our best to be here for you. Some people said, can we try different times of events, different formats? So do give us feedback. If something is working or not working, do reach out to us. I can see Daniela's presentation here. Just going to wait for her to put the, okay, she did it. Presenting mode, and I'll give the stage to her.
Okay, thank you. Sorry for this. Like, this is the actual proof that we're doing this live. We didn't plan, but okay. So this is a talk I'm prepared to talk about the career path of a data engineer, and this is something I've been specialized for the last 5 years or so of my career, and nowadays, like Amanda said, I'm a Google developer expert in Go and GCP, but also like my day-to-day job, I'm executive director in data architecture at JP Morgan. And okay, so what I prepared for you today. So if you're curious into this career of data engineering or data architecture, what can you expect about it? So basically, in the agenda today, I'm going to talk a little bit about career paths. For those who doesn't know, what is data engineering? What is data architecture? What kind of skills and technology do you need to know to be successful in this career path? And also sharing some learning resources. Everything that is in this presentation, I also publish in my public speaking repository. So the slides will be shared. There is no code in this presentation. I also need to make a disclaimer because Amanda was talking about cats, and I have 2 cats, and they might interrupt us at any point in time. So ask for forgiveness if that happens. So, okay. So let's talk about career paths. I would really love to say that, oh, wait a second. Okay, my screen is lagging a little bit. I really love to say that this is the data engineer path or data architect or any kind of career path. Okay, you start your life, go to college, graduate, and then suddenly you have a career. But as you know, life is messy, and you can see that actually my path is something like, okay, I started my career, my life at some point, and you see that the end is not aligned to the start anymore, because life usually looks like this. And as Amanda said, I'm originally from Brazil. Now I'm based in the UK. And actually, I started my career because when I was young, I really love video games, and I went to develop basically games. And so I started as a game developer as a hobby. That didn't go very well. Eventually, when it was time to pick up a college degree, I went to electrical engineering course. Then after a while, I said, okay, maybe I should invest a little bit in development. I need to work at Siemens, like working, basically building firmware, because game development was not very popular back in Brazil. And at some point, okay, I kind of got frustrated, and I said, okay, maybe I should go do something else. And eventually, I went to medical school. And after a while, I decided, oh, medical school is not so great as well. I tried to be a stockbroker. And after a while, oh, stockbroker is not so nice. Maybe I should try that thing about IT again. And then I joined this consultancy firm, Wipro. I discovered Oracle database and thought, oh, database is pretty cool. So I joined, I decided to be a DBA. I joined college again, this time to try to become a software developer. And when you think about, by this point, I would have found my career in IT, because you already know the future. You know, I'm here now. But then I took this turn and joined Oracle. And instead of working in a technical role, I became a salesperson. And so, yeah, you already got the idea. So eventually I got back to the software engineer track, emigrated to the UK, joined a fintech, and nowadays I'm at this point in my career, I'm a data architect. So you can see, I'd say the rule number one is basically your background doesn't matter. What's important in life is actually what you want to do. Do what you want to do. And the most important thing I would say is the process. As long as you're enjoying the process, everything else really doesn't matter. Like you can be anything that you want to do. So let's talk about data engineering. What is data engineering? I kind of struggle to find a textbook definition of data engineering, and yeah, I kind of come up with my own. And basically, I did a little bit of research in job postings and definitions and so on, and I came up with this definition that says basically, data engineering is the design, study, and development of data products, pipelines, and services to enable the business to have data-driven capabilities. And the key word here is enable. And I really like to say, like, if life is an adventure movie or maybe an RPG or something, data engineers and we are support characters. We are not the heroes of the story. But of course, we have a very important role, that is this enablement aspect of data-driven capabilities. But let's take those words and dig a little bit deeper to see if we have like a shared understanding of what is all those things mean. So starting with data, what is data? Data is like basically a measurement about something or like a record of something. But it's not just that. You need to care about what's the nature of data. Like, is the data you care about fast or slow? It's big or small? And you have all these characteristics that you need to care about. So when you are working with data, you need to think about structure, schema, formats, what kind of technologies, how fast can you deliver, how fast should you deliver? Like, does it matter if I deliver like real-time data if I only want to read this as a report every month? So those trade-offs are part of our day-to-day business. There's also the concept of data products. And I really like this definition that a data product, what is a product? A product is something that you can that basically delivers value. So a data product is a product that facilitates an end goal through data, according to DJ Patil. So basically, data with a product direction. I had a coworker that used to say, data is meaningless if based on it, you're not going to take any action. So think about it. When you collect data, and people are usually nowadays are obsessed with the data and say, gather more data. And one of the key questions I like to ask is, okay, if that numbers goes up, what are you going to do? Do you have any action to do? If that number goes down, do you have any action you should do? So this, especially if you're, even for other areas, if you have a monitoring dashboard, all those numbers, are you going to act on those numbers, or they're just for show? So this is the importance of have this product dimension, product direction. And there are a few more advanced thinkings. I really like, this is, like I said, you have access to this presentation layer, so you'll be able actually to click the link. But there's this concept of a data mesh that's kind of a new paradigm that combines domain-driven design with product thinking. If you're interested in this subject, I will recommend this reading. I also talked about data services. What are data services? Basically, they're services that facilitate the manipulation of data. So we're talking about encryption, masking, but also things that help you to do your exploratory analysis, deployment of models, all kinds of things that are not directly related to data, but helps you to achieve your objectives by manipulating the data itself. Those are data services. And data pipelines. What are data pipelines? This actually, data pipelines are the bread and butter of most of the engineers out there. That basically is the act of extracting data from a source system and publish it somewhere else. And why do you want to do that? Because usually this somewhere else is some place where you have more capabilities to analyze and explore that data to transform that data in value. So this is the diagram, is the basic format of any data pipeline. You usually have a source, you have some kind of technology doing the process in the middle, and you have a data sink, that's your target. And you might have or have not some kind of scheduler, depending on the type of workload. Like I mentioned briefly the idea of batch and streaming. Streaming, you imagine that's something that happens in real time. It's always happening in this flow. Batch is something that usually you can schedule and say, run on a day, run on per hour, and so on. Then in batch pipeline, is you usually have this figure of a scheduler. Also, we mentioned the business as, and the business is basically the reason why we have work to do. I used to have a friend that he would say, like, I'm glad that we have problems, because the fact that there are problems in the world means that they need someone to solve those problems. So we can have a job. But again, our objective in this field is to enable this aspect of data-driven business, so business can make decisions based on data, as opposed to pure intuition. Like we always seen that story, like that family business where someone makes their decision based on the wind or whatever. Of course, you can devaluate the value of experience, and there's a long debate on how much can we delegate to data and like wash our hands and say, oh, the data say that. So and there's no right answer to that. Actually, it's a mixture of both. You need some to use our experience as a human being, your intuition, but using data to inform your decisions instead of purely guessing something is what we really aim to achieve. So, and that's why we have this discussion nowadays about what's data-driven, what's data-led, and what's data-informed. So different of levels of approaches to this problem. And this is finally, in terms of handling business problems, this is a diagram I love to show people. Is like usually you have this chain of events, like you have a business requirement and you apply your domain knowledge, some kind of modeling, to reach a solution, and then you pick up a technology to solve a problem. This is how things should happen. But more often than not, what we see is things going the other way around. And I can give you an example. Is that something like, okay, I go to that big tech conference, something, and people say, oh, this technology, this is so cool, big data, this is so amazing, solves all the problem. And then suddenly the CIO, CTO goes and I'm going to buy everything big data, and throws at you, at your engineering team, and say, hey, I heard that this solves all my problems. Here's the tech, solve all my problems. And it's really not how this thing works. So it's our role as technologists to instruct the business on how to properly use the technology. So it's also part of our mission, let's say. So, and everything summarized to rule number 2. So technology is means to an end. Of course, we are all here because we love technology, but we don't work just for the sake of technology. We are trying to solve problems of the world. Let's talk about skill sets. What skills are required for a data engineer on a day-to-day basis? So I got this diagram from O'Reilly, and basically you can see that there's this confusion kind of, and there's a significant overlap in terms of skills of what is a data scientist, what is a data engineer. So data science usually are close to the maths and statistics, and data engineer are professions closer to the software engineering spectrum. I think this is, but they have some overlap where both should care about analysis and programming, but they have different expertise levels on those things. So usually the data science will care about model correctness, while the data engineer will care about scaling and applying the best software engineering best practices, so you can actually apply all the data scientist knowledge to production, to a real-world problem. And what kind of problem we're trying to solve as data engineers? And usually this tends to be summarized as what we call the problem of big data. And this is, you probably, if you have been in this industry for long enough, you will have heard like several definitions of what big data actually means. Some defined based on a number of V's, 3 V's, 4 V's, 5 V's, 6 V's, like volume, velocity, variety, all those things that nobody cares about memorizing anymore. But this is actually the first reference of the problem of big data in literature. It was published by some researchers from NASA. And the definition is quite simple and it's quite timeless. That's why I love, I think it's a really beautiful definition. Basically, when data sets are quite large, like taxing the capacities of main memory, local disk, and even remote disk, that's the problem of big data. So basically, in other words, if you need more than one machine to solve your problem, you have a problem of big data. And so to solve that kind of problem, a data engineer requires a mixed set of skills. And that will involve infra, software engineering, and data-specific technology. So let's say a little bit of those. In terms of infrastructure, we have traditional infrastructure, but also DevOps best practice. Like everyone today should know at least, very well, at least one public cloud provider. You should know how to handle Git, infrastructure as code, CI/CD, Docker, Kubernetes. You also should know, in terms of software engineering, algorithms, data structures, a few development languages like Python or Scala or Java or others. And on the topic of development languages, I think it's really useful for you to know at least one of each, in the sense like one compiled language, one scripted language, one object-oriented, one functional, and one maybe one imperative. And of course, you don't need to learn 5 languages. Usually you can group those together. So find the things that work better for you, because sometimes one language doesn't resonate a lot. But if you look for something else and try to do things different, you might learn so much. And because our brains doesn't work like the same. So really don't be discouraged by if one language is putting you down. Like everybody knows that I have a very public rant against Java, but of course it's a very popular language, so that's why I name it here. Anyway, there are a lot of libraries that you should care about in this field, like scikit-learn, pandas, and so on, but also practice like testing and TDD and so on. And then, of course, you get the meat of it, like data technology, like the whole Hadoop existing, processing events with, I don't know, Kafka, PubSub, that kind of things. We have this concept of analysis engines like Spark, for instance, which is basically our types of software that are designed to solve the problem of big data using distributed computation, making it more accessible for us to think in terms of distributed computing without handling all the complexities of this. And also some kind of workflow sharing orchestration. The gold standard here would be probably Airflow. And by the time I finish reading all those things and give you a few examples, the only thing I want you to think is rule number 3. Like the more you learn, the less you know. Like this is literally overwhelming, and you see, I mentioned a lot of things, and I really want you to know that you don't need to know everything. It's kind of like, because every time you start to explore something else will appear. Like and usually when I begin, you think, I only need to know this. And then you learn the thing, and you learn that there are 10 other things that things pose as a consequence. So even as data engineers, we might have different specializations. Like we can have data engineers that are more infra-oriented, data engineers that want to be closer to the algorithm, so they become machine learning engineers. And we also have the ones that are more focusing in traditional software development. They will eventually do backends and build the pipeline. So even if you don't know all those things, that doesn't mean you can't be a data engineer. That's what I'm trying to say. Finally, let's talk about some learning resources. And first thing I really like to develop, this is a very rough example of a learning path. And the learning path is basically, since I mentioned, like we have all these flavors of data engineers, all these kinds of technologies. So you really should try to make a map of all the things that are relevant to you, all the things you know, and what you can do next. So for instance, this is something I usually do when I'm mentoring people. We start with a whiteboard and draw something like this and see, I know R, I know a little bit of algorithms, and I know Airflow. And then, maybe I want to focus on data analysis. So, data analysis, maybe I need to learn a bit of relational database. Maybe I want to evolve to model training. Or maybe not. I just want to learn to be closer to the platform. And putting this on paper really will help you to plan ahead and think, what should I learn from time to time? Doesn't mean you can take more than one at once. So this is basically just an example. And in order to guide that, of course, everyone will have their own way of learning things. And for those who really like courses, there are a few here that I think are pretty good. Introduction to Algorithms from MIT it's entirely available on YouTube. This data science specialization from Johns Hopkins University is a very good one if you want to know about building models and using statistics. It's very, like the name says, data science oriented, but the foundations for every good data engineer are there as well. And I really love this course called Mining Massive Datasets. I think they have a book as well you can download for free on their website. And it's really, really, really good. I think it's the gold standard in terms of reference if you want to pursue this type of career. So here I have the link for the book. And also a few others that are interesting. Python and Scala, I think, are the most popular languages, most important for someone that wants to work in this field. Also Spark, very important. This Design Data Intensive Applications is a very popular book as well. In terms of engineering, today there is no production code without tests, and this is the I don't know, maybe the most popular book, maybe where everything started. Tested and developed by Kent Beck, and it's a very accessible book. I'd say the only drawback of this book is that the first half of it uses examples in Java, but nevertheless, I think it's a great book. The second half is in Python, so he kind of redeemed himself. But also, if you are close to infra, like Terraform, infrastructure as code is also something very important. Every production system nowadays should have its infrastructure defined as code. What else? Community. The community is a very important thing. Like talking to people on Twitter, connect to people you have. If you don't have anyone to connect to, you already have at least my ID. Go follow me on Twitter, send me a message. Also conferences and meetups like this one. Here are some specialized conferences in this field, or the ESC, Strata, Rexis. There are some very cool blogs towards data science is one of them. Of course, Stack Overflow. And that all leads to rule number 4, build your own network. And this is really important. Like nobody gets anywhere by themselves. And I wouldn't be here today without the community. So everyone is here to support themselves. I had help from people that came before me. So I'm always taking people like to mentor and do this kind of thing. So look, talk to your community. Definitely there will be someone willing to help. Maybe this is the burning question. Finally, I don't work in the field. What should I do? And I'd say if you don't know where to start, there is a very good place to start is open source. So all the most popular data engineering and data science related projects are open source, and they usually have great opportunities for you to start contributing. You don't need to be a rocket scientist to be able to contribute to something. Like sometimes people think, oh my God, Spark, Apache Spark, so complex. I'll never be able to contribute anything. But sometimes you can start pretty simple. You can start with maybe raising an issue, raising a question. You can contribute with the documentation. You can, sometimes you're using something, I can't find a good example of this. Maybe you can contribute to that with that example to the documentation. So there are many ways where you can start. And here, just as an example, like even Google, they made mistakes. So kind of this was an issue I raised some time ago. So yeah, and it's fixed now, and everyone benefits from this. So if nobody complains, people will not know what to fix. So this is also some type of contribution, but you can do this in many ways. So, and I would say the main advice, if you're looking to contribute to any open source project, like choose a project that you love. You can start as small as you want. Like I said, documentation, filing bugs, raising opening questions on Stack Overflow. And yeah, there's also some programs for people. This is mostly oriented to people who are transitioning careers or they're just starting, but have a look at Outreach. They offer internships in like big companies to work with open source. That's a very good, nice project. I know some graduates from that project that are very well today, so definitely recommend it. And so this is rule number 5, like always do open source, because this is really, you're helping the community and you're helping yourself, basically. Everyone wins. And so in summary, what I had to share you, if you were pursuing a career in data engineering, your background doesn't matter. Technology is just like a means to an end. It's just the background. The more you learn, the less you know. This will happen forever. Build your network and always do open source. And that was what I had for you. I hope you enjoyed. And I know, Amanda, do we have any time for questions or anything like that? I'm not sure. You're the boss.
We do have questions, and let me start with the first one. How can an outsider get into data engineering?
I would say, yeah, it's kind of the whole point of this is, first you need to get to know where you are. Like everyone will have their own career paths, like I was just showing you my own path, and basically every skill that you have, you can leverage it. But the path I chosen is, of course, study a little bit, like try to find the skills that you're missing the most. Like I started with that course in Johns Hopkins University in Coursera from the data science specialization. Of course, I knew a little bit of database before, but that's where I started specializing in this path. So courses can help, books can help, and the main question will always be, okay, I don't have professional experience, and that's where open source comes into place. So it's a combination of this, like study a little bit, invest in open source, and because think how cool it is. If you're interviewing for a position, they ask about, oh, you put Apache Spark in your resume. What do you know about it? And basically you say, oh yeah, I contributed to this project. I'm an open source contributor. And yeah, it definitely puts you in a different league, even if you don't have any experience in the field. So I'll definitely advise you to do this.
Okay, very good. So in case you have any more questions, Daniela shared her contact here with you. And thank you very much again for coming here last minute and giving us not only one, but 1,000 resources. You're like, you don't like books, you don't like this, you don't like that, you have everything. Here's all the resources. Thank you for sharing this with the community. And I think we can reward ourselves with dinner now.
Okay, thank you very much for inviting me, and wish you the best.
Thank you. Have a good one. See you soon. Bye-bye, everyone.
Bye-bye.